Okay. So this is a modular synth tutorial, but it is other things too. But the direct mode of comprehension, the direct relevance, it presupposes some knowledge of mathematics. If you're a mathematician, you'll understand it easy. If you do physics. So what I'm working through turns out to be part of a system, or maybe it's the full system. It's very Hegelian. We are to think of, in music, the circle and 360 degrees of a circle. If we remember, there is a so-called circle of fifths. Which never made any sense to me. I mean, I could see that the circle of fifths works by just comparing it to sound. But me and the piano keyboard are allergic to one another. Because the tempered systems that, or which emerge by necessity upon the invention of hammered string instruments. Any system that uses hammered string instruments where each string has a predefined tuning and the strings are struck by a hammer. Any percussion instrument, drums are that way, right? Got to tune the drums right. Every drum sound has its own tuning. Well, it's the same, of course, for piano, harpsichord, etc. You pull open the top, right? You see all the, I don't know how much we know about pianos. Not that I know, I know very little myself. I've never, although I would like to do prepared piano, where you do things like stick pieces of broken Coke bottles in between the piano strings and the whatever the rest of the body of the instrument. Anyway, the integration with if we call it the German way or the tempered way, I don't know how I'm supposed to refer to it, but tempered systems proceed, and because of the fact that you have to tune in advance discreetly, you have to define every single interval, right? every single difference. It has to be defined in advance, and then you're just playing over the system that's predefined. Now you might object and say, hey, well, don't you tune string instruments? If it's like a hammered dulcimer, you have to tune every string. But there's a depending on, like, take the example of guitar players. I think a talented guitar player almost wouldn't even have to tune any strings. Because, look, wherever you are, you've got one and you've got half and you've got double. So, if you've got one and you've got two and you've got three, it doesn't really matter where you define any of the specifics on your hardware. Because in order to get one out of a guitar fretboard, you just have to clamp the whole thing, right? And I don't know how they do it. You get half. I mean, but those are where the pure tones come from. They're just the very smallest whole integers in relation to one another. That's just intonation. That's just intonation. That's Pythagorean system, etc. Okay. So far, so good, I hope. What do I need to say next? All right. Okay, so as we've been going, and I touched this thing just very slightly, right? And if you notice, like, I don't know who's paying attention or what, but in the past couple of weeks, probably especially, the parameter settings, knob tweaks as it were, getting very precise, right? Well, it's because I'm thinking in geometric terms, every single step. I don't know if we can get to Planck level magnitudes. You know, those are physical magnitudes. You got to go talk to CERN. Super collider people. I mean, no pun intended. I don't mean James McCartney. McCartney. James McCartney. Okay. Yeah. McCartney. Okay. So you can see the precision is, I would say it's almost absolute precision. Where if we consider that there's just at its simplest sound, you know, if we consider that, I don't know, actually no, the square wave is the simplest. The sine wave is the most complex. As it's said, the sine wave, you generate all harmonics from a sine wave. So there is a sine wave. Now, I'm talking specifically about this patch, as it were. But it's not just a patch. I mean, it's just so happens to be the way that I'm thinking about music right now, but it has it has relevance to the war in Ukraine. I mean, geometric power, fuck yeah, it has relevance. Okay. We start, and there is literally, and I'm not going to, even though the reason why, okay, I never say, oh, I'm not going to lie to you. To be honest with you, and I'm not going to lie, okay, the reason that I'm going to say it now, that I'm not lying, is because I'm not sure how believable it sounds. Genuinely. The only real sound source of this patch is a sine wave. But it's not even clear what sine wave it is. We know what unit it comes from. It's coming from this. It's the VC, that's voltage controlled quadrature LFO. A-143-9 QLFO. And I have in mind, like, probably if Robert Henke ever heard this, he'd probably be like, dude, this is all 101 shit, dude. Okay, but there are plenty of people that don't know it, and I myself have just discovered the immense power, I mean the surgical precision that is possible with just literally almost no units. Pardon my nakedness, I have to turn the lights on. I mean, you can if I start contemplating how little gear you need Jesus. I thought the lights were, I don't know how many lights I have. Okay. No pun intended. All right. So, I really got to thinking about circularity in music when trying to figure out this darn LFO module. So, I can't get the fuss to bring the screen close, but it's, let's see how. I'm trying to scrutinize the screen. Sorry, it's very weird when we have like the whole chiral situation. Chirality, mirror images, left and right, video screens. Okay, you will see. Okay, maybe that's better. This is the LFO. The only sound in the whole patch It's hard to say exactly. I mean, this is the interesting thing is that there really is no fundamental, because if I now you'll start to get a sense of what's going on. So okay, let's presuppose we know what the concept of the fundamental period is, or the fundamental frequency. It's just an arbitrary place within the frequency spectrum, an arbitrary location such as A equals 440 hertz. That's a fundamental frequency. It's an arbitrary place, probably just because it sounds nice or whatever. It has utility in relation to other frequencies, pitches. An arbitrary place in the frequency spectrum upon which to start relating all of the justa intonation intervals. Everything is going to be based on that reference pitch or fundamental period. We'll call that unity. That's unity. It's the unity of a pure tone, such as the tone generated by 3 to 2. So this LFO unit, it has four outputs. It has sine 0 degrees. That's radians. Trigonometric Fourier way of thinking. So first output is 0 degree sine. Second output, 90 degrees cosine of the first. That's probably an incorrect way of speaking. I don't know. I mean, ultimately, it's all of the same circle. You get 360 degrees because the next step is, again, a sine, but that's at 180 degrees. So we're rotating steps of 90. And the final output is 270 degrees cosine. Now what happens is, if you use 0 to 90 and 90 to 180 as the first half of the circle, and 180 degrees to 360 degrees is the other half of the circle, which is just, the circle is just a sine wave cut in half and flipped, right? I mean, that's the other point. Literally. So a sine wave is a circle, but we cannot represent a sine wave as a circle in time because nothing will happen. I mean, you might get a pointer, but it'll just go round and round. Like, the Apple wheel. Your machine fucking crashed and you have to restart wheel, right? No, we want to represent a sine wave as a pathway through time. So first half, second half, first half, right? Okay. So the first pair, 0 to 180 degrees, top. 180 to 360, bottom. So that one unit breaks that, let's call it the musicological horizon. 360 degree circle, the musicological horizon. that VC quadrature LFO breaks it into 4 quadrants. Now, every single last part of your musical composition can originate in that darn unit. Because everything can come from a sine wave. It contains all harmonics. It's because of the circularity. I mean, it's a perfect circle. A circle is a perfect circle, is a sine wave. You know, I've taken electronics courses, I've taken math courses, or at least I've tried. It's only recently that I can remember that I really heard an in-depth discussion of the fact that, you know, hey, look, cut the circle in half and flip the bottom part and you've got a sine wave, right? So, out of each of the outputs, so when I say musicological horizon, I mean like it's the world. It's the total world of possibilities that we're in. The limitations that we're going to explore are not the limits of your psyche or your imagination. They're not the limits of history. They're the limits of this thing that's defined as 360-degree circle. Just call it hypothetical. I don't know if it's worth anything, but it's a formal description. So, you have one sine wave. There's 3 copies that are shifted in phase 90 degrees. The word phase is related to radians and trigonometric phase. Roughly, if there's a window, imagine that the sine wave is defined by a window, and you can start the curve that goes up like that. You can start it anywhere within the window, and that's like the total universe for phase is just horizontal. Is that 2 dimensions? That's one dimension. And you can start the wave anywhere, but you don't change. But the frequency remains the same. You can start the phase anywhere along that line. It means that the waveform actually starts there. So by moving incrementally by 90 degrees, we've divided the musicological horizon into 4 temporal quadrants. Temporal quadrants. You can start anywhere. You can finish anywhere. But we choose a location. That's what this knob is the arbitrary frequency. Now, the intuition was, and it still is. I haven't carried this very far yet. I can already see where it's going, and these are the preliminary moments of it. Okay, so I was working with this thing. They're Irish. Instruo Leon or Lion. L accent, that's like backwards accent, I-O-N. Like lion, but with an accent. So like lion, Leon. So you've got on the Instruo Lion 6 inputs labeled integers 1 through 6. Harmonics, whatever you like. Beats, whatever you like. The small integers is the point. The bottom row, though you can't see it, Greek letters, alpha, beta, zeta, no, alpha, beta, gamma, alpha, beta, gamma, delta, epsilon, zeta, alpha, beta, gamma, delta, epsilon, zeta. I think. 6 outs. And they're labeled with the Greek letters. Why? Pythagoras, that's why. Okay. It is a pin matrix, and the pin matrix works simply by having XY axis. You've got 6 inputs and 6 outputs, and by coordinating XY, you can pin location. So the reason why I was hesitant about saying, the basic sound source is that I began with this arbitrarily, anyway, this blue chord is going into this unit called the voltage controlled wave multiplier 2. A137-2 wave multiplier 2. Doper. So all we're working with is an LFO, which I did the quadrature LFO. 6-pin routing matrix. Now the Instruo Leon, each of those 6 jacks, it copies the voltage. So you can take the output of just one source. I think it would have to be designed that way, because it's very easy to copy things. Copying things. Okay, you know how two identical sine waves at the exact same time synchronize, they cancel each other, or no? Yeah, they cancel each other out, and so you have to invert, you have to flip the wave. You have to invert the wave so that if you've got the same source at the same time, right, that they won't get cancellation issues. But for synthesis, cancellation becomes a tool. So, which quadrant of the musicological horizon universe I'll just say circle. Which quadrant of the circle do we want to cancel? You follow? Now I'll turn it up. So right now, that change that I just made is so that we've got okay, no, I'm going to shut the fuck up about the cancellation stuff because I've only just started thinking about that. No, but the main point I've already made. I mean, because of the fact that we can use any of the inputs willy-nilly going into this voltage-controlled wave multiplier means that whether it's sound source or modulation becomes a fairly arbitrary distinction. See, so generally this is the idea is on the musicological horizon, 4 quadrants, total circle. Each piece of gear in the scheme, in the patch, is going to follow this principle of quadrature, or the 4 quarters. Now, here's where the cancellation becomes very, very real, because this actually happened with the next part. Okay, so there's this thing. Now we have 2 outputs left and 2 inputs because on the instrua, because it's 6. Remember, I said it's 6, and we've got 4 outs coming from the LFO, right? So what about the other 2? Okay. This is from Cynthia. Syndustries. Syndustries, is that what she called it? Anyway, it's Cynthia. Really, it's the four transients. So, this is conducive. It's because it's 4 units. It's 4 envelope generators. 4 quadrants. If we want 3 phase shifted copies of one sine wave, and we want to get gates out of all of it, we need to send it to a comparator, right? To get gates out of curves. You can't see it, but that's like the last piece of gear that's used in this is just this comparator. It's compare to, Jor analog compare to. You've got two comparators in there. Basically, you've got inputs and you've got conditions, and then it outputs gates. That's it. So, because of the fact that we've got sine waves that are 90 degrees phase offset going in to the comparator, right? We get the 90 degrees for 4 quadrants of the whole horizon, right? We have that in the Cynthia because we can send gates from the comparator that has already sorted out the 4 inputs, right? We can get gates out of the comparator, and then the gates will hit 4 envelopes. Not only that, each of the 4 envelopes, Cynthia has very cleverly put positive and negative outputs for each. So, you've got a lot in common, but you start getting differences. And so the way this is wired is it's positive right. It's positive from one and negative from the other. Now, it even would, okay, here's where the cancellation plays in. If we took positive from one and positive for the other, right? Then everything in the common is going to cancel. So if it's 2 identical, but they're not 2 identical envelopes because one is 90 degrees forward, or 90 degrees rotated, I should say. So anyway, that just, I don't know which wirings are arbitrary, and this is where my mathematics starts misleading me, so I have to shut up about that. But anyway, these roughly, those are the elements involved anyway, but regardless the logical specifics, you can see that's what I'm working with. I've just said it. That's everything. Oh, no, I haven't gotten to the, okay. The most important, well, it's not the most important part, but what creates the real material, the sonic material, is this voltage controlled wave folder. Because all it does, it only accepts, if you put, you should put only curves in, only sine waves, because any spike is just going to be duplicated. It's 4 phase shifted copies of the input. And there's manual, I don't know if it's a total 360, but manual setting for each of the four copies. Four copies. Did I say 3 copies? It's 4 copies of the input. So this is first quadrant. Second quadrant. Third quadrant. Time I touch anything, it's just going to increment by probably by 1 syntonic comma, which is 81 to 80. That's my presentation. I will say this too. Moreover, I have put into the wave multiplier a function directly from the function generator, this thing. Regal DG1022. It has 2 channel outputs. So you got, standard sine ramp, pulse, etc. Right? Okay. I dialed in. So we will use as a reference frequency 1 cycle, right? 1 hertz. So I dialed in, and I actually tested this with the wave multiplier. I dialed in, what was it? 25 millihertz. No. Or maybe it was 25 millihertz. Anyway, shit. It's the next step down from 1 cycle per second. This was, I think, 4 seconds per cycle. So the fundamental period was 4 seconds. So I mean, just by the logic of it, right? 4 seconds, 4 quadrants. Each positional copy in the wave multiplier corresponds 1 through 4. So if you position them 1, 2, 3, 4, and you only use, you make sure that they constrain each other so it's not completely out of whack and things aren't stomping on each other, then you literally have a compositional principle where you've cut any duration into 4, and then you've got control voltage inputs, variable intensity control voltage inputs for each copy, and you fix your pitches from there. I don't know if it's called phase modulation synthesis or comb filtering or both. Probably both. It's a full compositional universe. Just those units that I've just described. You literally could define a single cycle where the fundamental period lasted half an hour, and put that at the input of the wave multiplier, and then you break the half an hour into 7.5 minute chunks. Fucking powerful. Slavo Ukraini! Yeah!